focused on the container side of things. So we're going to be looking at a number of ways in which we can secure our containers. Yeah, this is going to be a fun session, hopefully a little bit interactive. If anyone wants to ask questions or add anything into the chat, feel free to go ahead to the GoToWebinar control panel, and you can put your questions and put your chat straight in there. Couple of things before we get started. This is a recorded session. We'll be sending this recording out to you after the webinar has finished. Plus, as a thank you for joining, we're also going to be sending you a bunch of Snyk swag as well as a meal voucher. So expect that to reach you shortly after the session. Okay, so without further ado, let's jump in and get started and talk about some of the best practices that we can look at when securing our containers. Okay. A little bit about myself, your speaker today. My name is Simon Maple. I am, in fact, the VP of Developer Relations, so I need to update this slide already. I'm only just got to slide 2. I'm the VP of Developer Relations here at Snyk. You're more than welcome to follow me on Twitter or email me. My contact details are just there on the left-hand side. I'm a Java person by trade. I was an engineer for around 12 years or so at IBM. What I really enjoyed was getting involved in communities. So I founded the Java Community Virtual Java User Group, also one of the co-leaders of the London Java User Group, and a number of other things you can see on my right-hand side there. But today, we're really going to be talking about how we can secure cloud native or secure your cloud environments. Before we jump into that, let's have a little bit of a level set here, and we'll start off with some definitions. So what we're going to be talking about here is largely the container side, but I wanted to kind of position that in the way in which we can see the shared responsibility, as it were. Now, the shared responsibility here that we're talking about is where security sits and who needs to deal with the security concerns. So when we think about how we deploy onto our environments, previously when we deployed onto the cloud, we looked at perhaps monolith application deploying onto a VM. We have to look after the VM. We have to look after the operating system, choose the operating system. We then deploy the app in our ecosystem of choice, and we have a number of functions that exists and sit on top of that environment. Now, when we look at the who owns the security of all of that, well, everything above the cloud platform here is responsibility of the person who is deploying. So we are, as a result, responsible for the app, the functions, the VM that it sits in, and of course the operating system that it runs on. When we think about the cloud platform that we sit on top of, and this could be anything, whichever vendor you choose, they really look after the hardware and the network. And so the security of the network, the security of the hardware, that is the responsibility of the cloud platform. So not much of a shared responsibility in this case. Most of the vulnerabilities, most of the things that you have to look after exist in your stack. Now, when we think about more of the cloud native space, the containers give us a number of different things. First of all, when we break up our application, we split that up. We split it typically into functions, which maybe follow a microservices pattern or something like that. But we can much more carefully distribute our functions within those containers and scale through our containers rather than scaling our monolith, which exists on a VM. This, of course, sits on a container orchestrator of our choice, maybe a Kubernetes or something like that. But the key thing here is the cloud platform still actually has to really only focus on things like hardware, those kind of things, because the VM is still hosting our containers. The container orchestrator is an addition from the previous monolith. The operating system, though, still exists within our containers. The code that sits on those still exists that we have to care about. So the split in responsibility still very much kind of like lays within our scope. However, when we move even further on that cloud native kind of like journey to pushing more and more into the cloud platform, we can see from a serverless point of view, the application is typically what we would be responsible for. And this is essentially the functions and the configuration that we push into a serverless platform. The host VMs, the operating systems, etc., gets pushed down into that cloud platform. So you would expect and you would hope and want the cloud vendors, then the cloud platform, to be responsible for those aspects. So we're going to largely be talking about this piece in the middle and looking at the different areas in which we could be vulnerable in that space. So when we think about our containers, it's very, very common for someone, let's say you're using Docker, someone to grab a Docker file, and as part of that directive, you use from and then choose a specific image. And it's very, very easy as a developer to just pick an image that works. We'll worry about which one we're actually going to go to production on later. Let's just get something working. Let's get something spun up. Now, it's very important which base image you choose, because depending on the base image you choose, that is essentially what is pulling in many, many different packages, many, many different services, which can contain vulnerabilities. So there are a number of different things, from versions here to the different whether you choose a slim or a different type of version, which really reduces the scope, reduces the platform that you're basing it on, and indeed the actual flavor of the image itself, in terms of are you using an Ubuntu, are you using a Debian image or whatever. And we can look into this in a little bit more depth, but we can see the number of vulnerabilities is increasing steadily with Linux distributions. And when we look at what this looks like in terms of our Docker images, it's hard to reduce the number of vulnerabilities that exist in our Docker images. We need to recognize that these are the 10 most popular images that exist on Docker, and this is actually from a survey that we did last year. And the top 10 most popular images of Docker Hub have a minimum of 30 vulnerabilities in there, and it's important for us to know which vulnerabilities are here, which vulnerabilities are fixable, which vulnerabilities even need to be in the image that we're pushing into production. Do we need that service? Can we upgrade a specific service, or even eliminate that service from our production environment? So recognizing where the vulnerabilities are coming into our application, and I say application meaning the whole cloud native application, including our infrastructure as code and our Docker container and the actual code that we push into, because more and more that is a developer issue. It's the developer that very often looks after a lot of these things. Okay, number two, that was number one. So prefer a reduced Docker image, and I'll show you some demonstrations about how we can go into that and how we can look at different vulnerabilities that exist in the demo section. Number two, least privileged user, and this is another one where our defaults sometimes let us down. When we look at a Docker image, for example, if we don't specify using the user directive, if we don't specify a user, we run as root. This is very often sometimes fairly well known, sometimes not known at all, but it's key that we don't provide unnecessary privileges for what the application or what the process is that we want to run is trying to do. So by specifying a user that exists in a group with just the necessary permissions to do what you expect to that process, that code to run on, that's the stage we need to get. It's very similar to the least privilege example of when you have a process that is trying to access a database. If you only need to read, you don't provide write. Why? Well, one, in case you are making mistakes in code, you want to make sure that you don't have the privileges to accidentally go and overwrite something or remove something. Secondly, in the security space, when someone, and I use the word when someone does hack in and breach, or should I say hack into your environment, you don't want to leave all the doors open and give them free reign of where they can go. You want to make sure that when someone breaks in, they just have access to the minimum resources and the minimum amount of content on your machine. So here what we're doing is we're creating a new group which we're calling SJ Maple. we're adding a user into that group, and this user, for example, is a system user with no password, no home directory, no shell. It provides a very minimal user. If you are using Node and Alpine as a great example, they actually bundle a generic user already, and this user is called Node. So this is an example of a limited access user which you can use not as a default, but it is created there so that you need to type in that penultimate line there, user node, which allows you to run that container under the user node. Okay, number 3, sign and verify images to mitigate man-in-the-middle attacks. Now, this is an interesting one that not everyone does, but I'll talk a little bit about how you can prefer signed images here. Not everyone has to sign an image, of course, but we can have these. We have these Docker certified images as a great example, which have to be signed. And this sign, the idea of signing an image, essentially means me as a consumer, I know that when I grab that and I check that that is a signed image, I know I can validate that this is the image, this is the byte for byte image that and bit for bit image that the publisher actually uploaded. There is no man-in-the-middle attack which sits between me and that publisher that has in some way maliciously augmented that image. So I know byte for byte that is the same image that the publisher uploaded. This provides us with the knowledge that this is the assuming we trust the publisher, that this is an image which hasn't been tampered with. Now, Notary is a tool provided by Docker, which allows you to sign images, and it also allows you to validate and verify that image signatures have been signed correctly, and actually prevents you from blocking images if signatures are invalid. And I believe actually there's a Notary 2 which has also been released by Docker, so do check that out. Another way you can test this is actually by enabling this environment variable in your shell, Docker content trust equals 1, and what this will do is it will fail pulling images that are unsigned. So you can actually just add this into your shell, run your scripts that pull everything down, and start building everything, and you'll see straight away that some things aren't being pulled down if they are not signed. So a nice little quick one-line test for you. Number 4. Okay, so when we think about the container, there are and how an attacker might try and gain access to a container, one of the key ways in which they do so is through known vulnerabilities. And there are a number of places where known vulnerabilities might exist. With containers, of course, we pick the operating system, we choose the operating system that we want to bundle in to that container. And every operating system, as we know, is going to have some kind of list of vulnerabilities, hopefully very, very small or zero, but most of the time this is a significant number of vulnerabilities. So what we want to do is be able to find and fix where our known vulnerabilities that exist in our open source container, in our operating system exists. Now, a couple of things that we want to do here. First of all, we want to make sure we scan. This is from that, this is from a different report that we did last year called Shifting Docker Security Left. And this was a report that looked at when, as part of it, looked at when people used to test, or people test and scan their Docker image for vulnerabilities in the operating system. And you can see that people tend to do this at build time if they do choose. Again, this is a multi-choice question, so numbers will surpass 100, which is nice to see, as it means people are testing in multiple places. But only 1 in 5, less than 1 in 5 people test during development. One of the sad things is here, 1 in 2 people don't test at all. So a little bit shocking to see that. But yeah, this is typically when people would do that at build time, and typically in a CI/CD environment. Now, if you wanted to use Snyk as an example to do that, you could do it via the command line. And in fact, this is slightly out of date. There is now a Snyk container test command, but it's going to be very, very similar, where what you can do is you can run Snyk test, which passing a Docker file perhaps, or using a tag like we can see here. And after pulling that, you can test to see if how many vulnerabilities exist in your Docker image, what the vulnerabilities are, what the fixes are for that. An alternative way of doing that, if you're a Docker user, is to use Docker scan. So if you just type Docker space scan, this is actually going to use Snyk under the covers. We have a partnership with Docker, so this is going to test your Docker image effectively against our vulnerability database, and it will report back which vulnerabilities you have in your open source, in your operating system that you have bundled in that Docker image. Now that was looking at a point in time at how many vulnerabilities that we have, how many known vulnerabilities that we have in that image at that time. But what about when we go to production? How do we find out about new vulnerabilities? And vulnerabilities are becoming known all the time, every day. We update our vulnerability database daily. So how do we know? How should we be notified of a new vulnerability that exists for some of our production containers? So most people use scanning tools. It's really a little bit hard to kind of keep track of public databases or non-public databases as well, and make sure you can do that reliably and timely. So most people use scanning tools to kind of do all the hard work for you. Some people rely on the security team to inform, I expect the ops group or the developer team or the DevOps group to update their images there as needed. Again, almost 1 in 2 people won't know of new vulnerabilities that exist. Now, what we do here at Snyk is we use something called Snyk Monitor. So the second piece here. And what Snyk Monitor does is it takes a snapshot of our existing Docker file, and what it will do is it will make sure that we test every single day to see if there are any new vulnerabilities that weren't there in our previous snapshot. So this is going to notify us as soon as it recognizes a new vulnerability exists that didn't exist previously. Now this is super important because known vulnerabilities doesn't mean, if you don't have any known vulnerabilities, that doesn't mean, of course, that your image is vulnerability free. That just means that we don't know about the vulnerabilities that still exist in your either application or Docker image. So as and when we find out about them and those get publicly disclosed, they'll hit a database. We will then tell you that has existed. Obviously, we have our own tooling, and we can grab insights about how users behave around their vulnerabilities and around their remediation. A couple of things that we can see. First of all, almost 1 in 2 Docker images have had vulnerabilities whereby they weren't on the correct base image or parent image, and by moving to a better, more secure base image, very often just a minor upgrade to that base image, that will provide you with a more secure image. Another interesting thing is 1 in 5 Docker images that have been scanned, the remediation advice that we can provide in 1 in 5 is that if you just rebuild that Docker image, because updates have been released, a newer version of perhaps a package will exist, and that newer version will be pulled in instead, and as a result, that will fix at least one vulnerability that exists in that Docker image. So 1 in 5 just needs a rebuild in order to actually make it more secure. So very interesting stats there. So we're going to do a hack quickly, just to show you a bit of live hacking as well, but also to show you we'll show you some scans and things like that afterwards as well. This is many of you may have heard of ImageMagick, a package which does image manipulation and displaying on the Debian environment in this case, and this ImageMagick vulnerability exists because of an input validation that is missed or circumvented, and this input validation allows us to further execute remote code on the remote Linux operating system. So let's go terminal and let's show you exactly how this works. Okay, what I'm going to do first of all, in fact, is just go to this. this full screen so you can see it a little bit easier. This is just a very simple Node application. And this Node application, I can choose a file. So why don't I pick an image? Let me grab a new tab. Let's find a nice cat there. Oh, that was a good one. Oh, space wobbles. That looks cool. So let's grab an image. There we go. Okay, I'm going to choose that file. And what this application does is I can upload an image and then convert that image to a Twitter photo size. So I'm going to choose a file. Let's grab that screenshot just there that I just took. There's my screenshot. I click resize and it provides me with the correct resolution that I can upload for my Twitter. So very, very straightforward. But what I'm going to do this time around is I'm going to go to, let's find Snyk, there we go. And in Snyk, I'm going to go to this goof container by breaking in project, click on exploits, and I'm going to pass in a JPEG, in this case RCE1, so remote code execution 1.jpg. Not holding much back there in the file name. We can probably guess that. Oh damn. We can probably guess that this is going to be a remote code execution, but we're going to open this one. Now, before I click resize, let's quickly take a look at what is in that file. So where am I? I'm in the correct directory. Excellent. So let's cat, make this a little bit bigger. Let's cat that file, RCE1. And upon catting that file, we can see, what are we going to see? We're going to fill this view box here with a URL, and that URL that we pass in is going to have, this is a very common thing in when attackers try and hack. What they try and do is without input validation, they try and put an illegal character in, like trying to close a string off, and then perhaps trying to do a touch of RCE1 or something like that. And what this does as a result is it tries, the command touch allows us to create a file. So this is an executable command, and we run that file locally on that machine. So let's see if we can do that. First of all, what I want to do is I want to show you there's nothing up my sleeves. Let's find this one. This is the, let's make this a little bit bigger again so you can see. What I'm going to do is I'm going to Docker exec this and jump into a bash environment. I'm going to quickly do an ls there so you can't see an RCE file there. So when I actually execute that upload and perform that resize, we're going to try and execute touch RCE1, and that's the file that's going to be created in this home directory. So let's go ahead and click resize. And there we go, image resizing success. There's actually nothing there, but let's have a look at what happened here. There we go, RCE1. So that was a touch command which effectively ran here. So I can see touch whatever. My name's Simon. So if I do that, there we go, Simon exists there. So that is exactly what we ran. This time I am running it from a terminal, which is fine. But previously that was run just by uploading a file here. Okay, let's do that again, but let's do something a little bit more interesting. This time around, I'm going to upload RCE2. Okay, before I hit resize, let's take a quick look at RCE2. So let's cat RCE2, and before I do that, let's clear the screen. .jpg. Okay, this time we're doing it in a subtly different way, but this is absolutely fine to do it this way as well. This time we're going to have an event when we do an image over, something happens. What happens? Well, in this case, we are doing, as part of an input to this URL, we are performing, this is like a little backtick, this is an evaluation. So we're going to evaluate everything between these two backticks, and the output of that will be added to this URL. Now, when we evaluate this, and this is going to be happening locally when we actually upload this file, when we evaluate that, we're going to do a wget, and we're going to pass that, what we're going to pass, something which is hosted on port 5000 of the Docker internal. So that will be my local machine that's running this Docker environment. And that local machine, well, it's going to download r.sh, and then it is going to put that into a local file called r.sh, and then it's going to run it. So let's take a look at what r.sh is, and in fact, that is in this directory as well. So let's cat r.sh, And what we're going to do there is we're going to wget netcat. So that's going to be an interesting one. We're going to extract that. We're going to tar minus xvf that. We're going to cd into that directory once we've unzipped it, and then we're going to run netcat, trying to connect again to an internal port on my machine, 3031. Okay, so there's a couple of things we need to set up here. First of all, I'm going to run netcat here locally. This is going to be my listener. So that is the port 3131. That is the port that the container is going to try and connect to. And the second thing we need to do in this directory, so if I do an ls, this is the directory which contains the netcat binary as well as r.sh. What I'm going to do is I'm going to serve from this directory, and that's serving on 5000. So let's go. Let's just one more time describe what we're going to do. On uploading this file, we will execute what is in this evaluation here. So this is the contents of the file we are uploading, and we're going to evaluate that. This is going to, on the Docker container side, we're going to perform a wget over to the host Docker internal port 5000, which I just served, which is this directory. It's going to grab the contents of r.sh, pipe it to a local r.sh file on the Docker container, and then we're going to run that in a bash shell. R.sh pulls down, does a further wget, it pulls down from the same served location the netcat binary, which we extract and then perform a netcat connection back over to my laptop on port 3031, and we are listening. This is effectively going to be a reverse terminal. We are listening here, and as I type things in here, I should be able to execute them on the remote machine. So let's go back, let's click resize, and hopefully nothing will happen. And I say nothing will happen, and that's because what's happening on the other side is we're performing a download of the r.sh. We're now performing a download of the netcat. We're running a connection on the extracted netcat. And if I type ls here, there we go. That is a reverse proxy effectively into my container. And here, this is just my local machine. I can now do what I want. I can ps minus ef perhaps, and this is stuff that is happening on that remote system. I can work out where I am. I can start executing things and finding information about that Docker container. So this is a very interesting reverse proxy into that environment. Okay, so those were a couple of quick demos. A couple of other things that I wanted to show you. Let me close that down. A couple of other things that I wanted to show you. If I just I'm in Snyk now, by the way. This is the Snyk dashboard. I'm going to jump very quickly over to another organization where I want to show you, in fact, I can click on this one here. I want to show you a project that I've already scanned. This project, the source here is Docker Hub. So I've directed this scan to Docker Hub, and it's now scanning that a specific image on Docker Hub. That image is a slim base image, sorry, a slim node image at version 10.4.0, and I can see a whole bunch of information about that. So if I click open this, I can see my current image with my base image version. I can see how many vulnerabilities exist in that and the breakdown based on the severity of the vulnerabilities in that image. I can also see some of the advice about which image I should go to. I can see by doing a minor upgrade, so going from 10.4 to 10.22, this will significantly reduce my vulnerabilities down to 74. And most significantly this is focusing on my my high sev vulnerabilities. So interestingly, more low sev vulnerabilities, but we're really cutting down our high sev vulnerabilities there. I can also do a major upgrade to 14.11.0, and there are 73 vulnerabilities, so one fewer medium sev vulnerability. This is an interesting one because what I can see from this is the node folks do an excellent job here of backporting vulnerability fixes. As you can see, it's likely these are going to be all the same vulnerabilities, backporting back to node 10, obviously. There are also alternative images. So if we were happy to change the type of image, so going from a slim here to a buster slim or a stretch slim, etc., we might be able to get down even lower. So you can see the lowest here is 54. Now, a couple of things here. Obviously going from a node slim to an upgraded node slim with a minor upgrade, this is obviously going to have very little impact on our application, you would expect, because typically this is just a minor image upgrade, and as a result, you might see some additional updates and things like that to existing packages. If I were to go from a bigger image down to a slim, and that would be the change, the slim is going to have a reduced subset of packages that I might want to use, and we just need to make sure that that is acceptable for the application that we want to run on. We still want to make sure it's functional, right? So it's just making sure that the image that we use is appropriate for our application. Now, a couple of other things we can see if we scroll down. You can see, first of all, the dependencies, and secondly, the issues. So the dependencies, it creates a dependency graph of the packages that we pull in, both directly and transitively. So packages have dependencies on other packages, etc. And here what we can see is where the vulnerabilities, what the vulnerability is, more information about that, whether it's a high sev, etc., whether an exploit is available, and how mature that exploit is, what version this is fixed in. This is an important one, obviously, for us to be able to upgrade, and how that is introduced into your environment. In this case, this is introduced directly through a base image. There are a number of paths as well in which this can go through. You can see here it's very direct, and there's a number of others where it's transitives to others, so coming through the system helpers package, etc., all the way to proc PS at the end. So what we need to do is we need to make sure that we reduce the number of ways in which this is introduced. We can't just fix it in one place. We need to make sure it's fixed everywhere. We also have a prioritization score here, and this is really important when you have projects with large numbers of vulnerabilities. We need to understand which ones we need to fix first, which ones are going to potentially affect us, or more likely to affect us. And this priority score is based on things like whether exploits are available, whether fixes are available, as well as the type of vulnerability. Is it something that could potentially hurt me more than other vulnerabilities? So you can of course look at your reports and then determine which ones from an ordered point of view are the most important ones to fix. Okay, and of course, the list goes on with all the information about all those images. There are a couple of other things that we do. Some of the vulnerabilities are based on the OS packages. Others are based on some of the key packages, key versions key binaries that exist in that image. And in this case, this is a node image, and as a result, node is one of the key binaries that we scan, and we can find vulnerabilities that exist in that binary as well. Okay, so let's jump back over to the slides, and that's here. Okay, so another really important, and this is important, I think, for whether you're using application development or creating a Docker file or something like that, is to use linters. And linters is a great way of policing some of the policies and rules which you want to instruct your developers, your development teams to follow. And in this case, you can run a linter, which can be run obviously locally or across a build, whereby it looks through your Docker files and it will tell you about best practices that you should be following, and some great examples here. Let's take a look. Use copy instead of add. That's a commonly known, I think, security preference to use copy instead of add for a couple of reasons. Man in the middle attacks is one. Separating a specific download from an extraction of a zip file, for example, being another, to remove or reduce the chances of a zip slip style attack, and a whole bunch of others there as well. But this is a great way of actually failing builds or seeing if there are things that can be stopped as early as a developer is writing them. Okay, now when we think about our containers, we need to also think about the applications that run in our containers. And one of the key things here is making sure that the open source vulnerabilities that we are pulling into our application also are free of known vulnerabilities. So as well as the operating system, another great attack vector for an attacker is trying to attack the app that you're actually hosting within that container. When we think about your application, we look at the code that you write actually is the smallest piece of the application that you deploy. The rest of the app, which many will say is around 80% or more of your deployed app, is actually open source code that you pull in as a result of pulling in a number of dependencies. Now, one of the reasons why attackers do target open source code is because one vulnerability equals many victims. One of the great things about open source dependencies and projects is that they're very reusable. But when a vulnerability exists in that, all of a sudden vulnerabilities will exist in many sites that use that library. Let me show you a couple of, I'll show you one more slide that I think is very interesting. And this is from the application developers' point of view. The ecosystem in which they live in will create a dependency graph of direct and transitive dependencies, direct and indirect dependencies. And this graph here shows what percentage of vulnerabilities are typically found in transitive dependencies versus direct dependencies. So in this case, if we take something like npm as an example here, we can see that less than 25%, you're probably looking at what, something between 15–20% of the vulnerabilities that are found typically in application scans exist in direct dependencies, but the vast majority exist in transitive dependencies. So these are the dependencies that our application pulls in because our dependencies need them, but they're not actually directly pulled in by us as developers. We're not explicitly stating that in our build files, but obviously, the ecosystems that we live in create these dependency graphs and dependency trees. So let's show you an example of one of those hacks. Let me jump over to actually, I just need to do this. So what I'm going to do is I'm going to jump over. Why don't we jump back to my org, and I'm going to jump over to the integrations, and as part of this I'm going to pull in an application into my dashboard, and the application I'm going to pull in is going to be the Goof application. So what I'm going to do is I'm going to grab that Goof application there, and I'm going to click Add Selected Repositories, which pulls it in to my dashboard. And there's a number of ways in which we can, which we as in Snyk, sorry, can find different artifacts that we can scan. For example, if I click on this to show the last log, we can see that we found a package JSON file. So this is a Node application. I can click on View Project then, and we can see all the vulnerabilities. And of course, this is very similar to what I just showed you from the container point of view as well. I can see all the vulnerabilities here that exist in that application, and again, have priority scores based on the vulnerabilities themselves and whether exploits exist, etc. Now, I'm going to show you a very quick directory traversal. There we go, a directory traversal vulnerability, which exists in the module ST. And this is a module, it's a node module that allows a user to serve static content, or a developer, sorry, to serve static content. Now, if I wanted to fix this, if I look at this actually first, this is introduced directly through the ST library at version 0.2.4. I can fix this by jumping up to 0.2.5, a nice minor fix. So what I could do is I could remediate this instantly just by clicking on Fix This Vulnerability. This will then show me my full list with the directory traversal selected vulnerability there. I can click Open a Fix Pull Request, and I can do this because I connected Snyk into my GitHub repository there. And what that is automatically going to do is send, and if I make this a touch bigger, make an update to my package JSON to upgrade from version 0.2.4 to 0.2.5. Okay, but I'm not going to merge that. I'm going to hack that. So I'm going to jump over to the actual application. And in the application, this is the goof application. It's just a to-do, so I can do things like let's buy some milk, for example. I can also see there's an about box here, an about window here, and this about is going to be serving some content from the public directory, and it's the about HTML which the ST library is serving. So if anyone has any ideas, feel free to post them in the Q&A or the chat if you want to play along by hacking this with me. But what I'm going to do is I'm going to copy that and I'm going to jump back over to my let me see if I've got a yes, this one will do just fine. I'm going to, rather than do this at the browser, I'm going to do it at the command line, and here I'm going to curl that same URL, this about HTML URL, and I can see that this is the same HTML that was just displayed in my browser. But what I want to do is I want to do a directory traversal. So how can I do a directory traversal? Well, one might think to do a directory traversal, I need to break out of a directory, right? The vulnerability directory traversal is breaking out, traversing out of a directory that I likely have a public access to, such as the public directory. How do I break out? Well, I do a .. and I try and break out into a private space that I shouldn't have access to. So I do a .. and we get sent back. Here's my buy milk. We're sent back to the home page. So you can see this is the goof to do homepage title. Okay, so I'm back onto the homepage. Why should I be on the homepage? Well, the ST library recognizes I'm trying to do a directory traversal and stops that. Okay, so it recognizes .. isn't allowed because it's trying to traverse out of this public directory. It stops that. So what I need to do is I need to represent that in a different way. And the way I'm going to represent it is with a %2e. Now, by using %2e, what I'm able to do is URL encode those dots, and by URL encoding those dots, the ST library, when it does its sanitization, can't find the dots because it's represented in a different way. As a result, when I do that, you can see I've traversed out of that public directory. So I've traversed out into the parent directory of public. Now, what can I do here? Well, let's take a look. I have a Docker file here, so maybe I want to have a look in my Docker file or my Docker compose. So I could just paste that there, and bang, there's my Docker file. What can we see? Well, I can see here I'm actually using what version of Node I'm running. So now all of a sudden I know which vulnerabilities are going to exist in this image. What else can I see? Okay, we're using copy. That's okay. We're exposing some endpoints. That's interesting. Yeah, this is the one that I'm running on now. There's no user, so this is running as root, and that's really interesting if I'm running as root. So let's see what I can do if I'm running as root. Well, maybe I can access things that I shouldn't have access to. So let's see if I can go all the way, in fact, to the root directory as root. Maybe if I'm running as root, I have access to files that I shouldn't be allowed. There is the etc password of that machine. Other things of that Docker container. Other things I can do, well, as I'm in the application, what I could do is, look, there's my app.json, there's my db.js, app.js. Maybe what I could do is take a look at some source code. There's my app.js. Maybe what I could do is have a look at my package.json. And by looking at my package.json, I can see all the direct dependencies that exist of that application, and I can find another way in, which perhaps will give me, while I have root access here, that's great, but I only have read access because I'm going in just with curl and trying to read content from the ST serving privileges. So maybe what I can do is I can look in here and try and find another way in. So what can we see? Humanize MS makes use of MS at a vulnerable version. I know that. So with Humanize MS, there is a vulnerability that has a regular expression denial of service. What else do we have? Express has a number of vulnerabilities. Dust.js has a, if I'm not mistaken, a code injection vulnerability. Lodash has many prototype pollutions. jQuery has a bunch. Marked has an interesting cross-site scripting. So as an attacker, I can start seeing alternative ways in which can increase the number of my privileges, or what I can actually achieve by executing rather than perhaps just reading. Okay, so when we go in and think about how we can. Let me go back to this one here. When we think about how we create our applications, not just with the source code that we write, but with the open source libraries that we pull, we need to make sure that all of our dependencies, that we have 411, that we're using the right versions, where fixes are available, we can upgrade to those right versions, because this is, for me, actually more important than security testing our own code, because these are known vulnerabilities that attackers target on the web. Knowing the exploits and how to break in. Okay, let me jump back to my presentation. Here we go. Okay, so multi-stage builds for small and secure images. This is an interesting one, particularly based on your application or your ecosystem. So, for example, my background is Java. We just don't jump straight to our runtime with our code like I just showed you with the node code that we had running on that application. We would have a compile stage, but that doesn't mean we would need to have everything that we require on the container to actually perform the compilation. What we would do is we would have a couple of stages, and the next example is Golang, a couple of stages where we have two separate images, and this is the multi-image build, where image A is a very big image. Okay, this is the large image that allows us to build our application, create our application, run tests on that built application. But we don't want to ship with all of that. So image B allows us to mark which pieces of image A we actually want to move into our final image that we then publish. So this is a very thin image, which just contains our production-ready part of the application. And again, when we reduce the size, we reduce our footprint, we reduce the threat risk that we take to production. Okay, so in summary, prefer minimal base images. I showed you how you can look at that with Snyk as well. Secondly, make sure that you're running things as the least privileged user. So in your Docker file, for example, make sure you first of all use the user directive, and secondly, make sure that the user that you point to has reduced privileges, so you're not providing them with access to things they shouldn't have access to. Make sure you're using signed images, and make sure you verify that when you do pull images down, you check that they're signed. I'll clump 4 and 6 together here, that when you have known vulnerabilities, either in your operating system, in your container, or the dependencies that you pull in your application, make sure they are as free as you can make them from from known vulnerabilities. And if you must deploy with certain vulnerabilities, understand the risk, understand how you could potentially be defensive in your code, perhaps, about how those vulnerabilities could be exploited. Make sure you understand the risk. Make sure you understand what is, which areas of your application you need to secure, and make sure that those are the ones that you focus on first to really reduce the risk of what a potential breach could be like. Jumping back up to number 5, use a linter. This is a great way to police the code that goes through, and this is both actually for the application and the container, but the Halo lint that we gave as an example, it will look through your Docker files and provide you with some great advice on the Docker files. And then finally, use multi-stage build. So if you do have preparation that needs to go in and executed within your container before you actually push it to production, think and ask the question: do you actually need all the artifacts, all the things that you are preparing? Do you need to push them all to production as well, or are they actually just increasing the risk that you're putting out onto your production environment? That is everything I have. I'm happy to take some questions. Feel free to drop them into the questions tab in the GoToWebinar panel. I can see straight away I have a number of questions in here. So let me stop sharing so you can probably see me a little bit easier. There we go. Okay, there we go. So Couple of questions. Let's take a look. Brian asks, how are you determining the severity level? Yeah, great question. So yeah, the severity is, CVS, the scoring. So if I was to in fact go back to, oh, I'm not actually sharing my screen, but the CVSS scores are effectively like a questionnaire almost, that when a vulnerability is disclosed, the discloser will go through a number of these questions to state what the impact is, how, if there's any setup required, if you require significant privileges to get into those, to exploit that vulnerability, for example. And as a result, you'll be provided with a CVSS score. Our severity, the high, medium, low, is based on that score. Now, the priority score, which is subtly different, because that is a score given based on your application or your container. Just because a vulnerability exists doesn't mean it is necessarily accessible, or it might not be fixable depending on where it exists in the dependency graph. That priority score is specific to your application. So the CVSS score and the severity provides a vulnerability focused view. The priority score, which we provide, is based on that scan. Thank you very much, Scott. Not a question, but just wanted to say that was a good webinar. Thank you very much. Appreciate that. Let me see if there are any final questions in any of the other places. So question, does Snyk, this must have been an early question, does Snyk test your own code as, oh no, sorry, I see, test your own code as well as your dependencies? So yes, this is a great question. So obviously with your application, looking at the application point of view, you will write code, custom code that you will write in your IDE, and then you will make use of dependencies that you pull in. Typically during build time, it'll create your third-party dependency graph. Now, the piece I showed you is what we would call SCA, which is a software composition analysis, and that is the testing of known vulnerabilities within your within that built application. But what SCA doesn't do is look at your actual source code. That is a different type of security testing called SAST, S-A-S-T. And again, it is a static analysis of that. So in the same way it's a static analysis that we do with SCA, this is a static analysis of your code. What we have announced actually at SnyckCon is the release of a product that we are calling Snyk Code, and Snyk Code is an AI-driven SAST, developer-first SAST product that looks at your code and provides you with information about where vulnerabilities and security issues exist in the code that you are writing, based on real-world examples, which is where that kind of like AI-driven methodology comes in. It's actually a product which is based on an acquisition that we made last year called Deepcode, and Deepcode was a product that and a company that allowed you to, using the same techniques, find more quality style bugs, QA bugs, in your environment. So that's how we also how you also find that. Simon asks, is zero vulnerabilities in production images possible, realistic, or should we always expect that there are some and apply other compensating controls in our application or infrastructure? Excellent question. When it's part of me wants to say it's easier in applications than it is containers, just because of the sheer number of vulnerabilities that exist in containers. But I think first of all, applying fixes. I didn't get that. Could you try again? Sorry, Siri or something's just talking to me. I think when you apply fixes to your application, it can often be harder than applying fixes to your packages in your operating system, because typically you don't expect breaking changes when you make updates to a package or an operating system, whereas in an application you're far more likely to find breaking changes if you was to upgrade a direct dependency to a major version or something like that, because people change interfaces, often not caring about semantic versioning. So it's often harder to actually make a fix in your application, because you then have to have considerations to changing your application to realign it with the new interface or new API. It is absolutely possible. However, sometimes it depends on how your dependency graph is built to make to find fixes that exist, because if a fix exists for a vulnerability but that dependency is buried 5 levels deep in your application, then sorry, let me move Siri out of my voice. If you are if that fix exists for that direct dependency, but that is many levels deep, you need to rely on every single other dependency that is a parent to that vulnerable package. You need every single one of those to also pull in a version that has the fix. So it's not just enough for a package maintainer to push out a fix, but you need the entire structure to fix. Snyk actually also provides something that we call patches, Snyk patches. We prefer the upgrade because you use a real version, but what we will also do is backport some of the like the 1-2 liners back onto a previous version, and we will do that using a binary diff style patch, so that if you are using a very popular library but rely on other maintainers to pull that in, and that isn't available just yet, we can automatically patch that for you. Okay, let me see if there are any other questions. Can you use Snyk on-prem? Yeah, absolutely. We have on-prem. We have everything I showed you today was SaaS, S-A-A-S, so entirely cloud-based environment. But you can also use Snyk on-prem. There are 2 different versions of that. One is a brokered version where it's an open source container that you can see what gets sent across to Snyk. That a lot of the time is absolutely fine for many different security policies, depending on the restrictions that you have in your companies. The second option is around full on-prem, which is literally unplugging your servers and everything will still work. Everything is hosted locally, everything is scanned locally, and even the dependency database, vulnerability database is local to those machines. You just need to make sure that that is up to date. And one final question, I think we just about have time. How do you get wide adoption from developers? And this is a real key question. I think this is interesting for a number of reasons, because more and more when we think about how security is rolled out across companies and organizations, and how the vulnerability profile that we have in those applications is handled, there's only one way that we can really add security into the process to scale at the same rate that we are pushing code to production. And unfortunately, that's not with the security teams. The security teams are extremely important to be able to support the development groups and enable the development groups, but ultimately the responsibility and the people who need to not just fix but also test and be responsible for the code that they push is the developers. So the way to gather the developer adoption, that's the reason why the developers are important, but the way to get that developer adoption is twofold: UX and making sure the flow of a developer isn't broken by the security tooling. And the way we achieve that is by, first of all, making sure we integrate with everything a developer does. So for example, if you're in an IDE, we'll provide that tooling in an IDE. If you are pushing to GitHub, we'll make sure that every single pull request that goes to GitHub is automatically tested to make sure you're not regressing. We'll provide CI/CD support so that as jobs go through your CI/CD pipeline, they're automatically tested. Builds break as and when you choose they crash through a threshold that they can break then. You get notified through pull requests, not just emails, but by pull requests when new vulnerabilities are heard of or a new fix is available. So that's the first stage, integration inside the existing process. But the second thing is the developer experience, the UX and developer experience. And the key thing there is not just providing a developer with the notification that there's a fire happening in their room, but telling them where the fire hydrant is, where the extinguisher is, and showing them how to actually fix that. And what we do there from a security point of view is, like I showed you, not just telling a developer, here's there's an issue with your base image, or there's a vulnerability here in this open source package, but we tell you how you can go about that fix. We'll tell you, here's a pull request. You can automatically create a pull request which fixes that. We'll tell you what version to go to. We'll tell you what preferred base image will eliminate that. We'll tell you what version of your operating system package you need to go to eliminate those vulnerabilities. So that was a twofold answer. Sorry, that one took a while, but I feel like I'm quite passionate about that answer. I feel like that is the key thing to get